Hi, I'm Joshua Cook, and I'm a curriculum developer with Databricks. In previous videos, we were looking at the natural language processing technique, Latent Semantic Analysis. In particular, we applied this technique to an analysis of two children's books, Goodnight Moon and Where the Wild Things Are. In this video, we're going to modify a step in the latent semantic analysis process to see if we can reduce the noise in the topic encoding of our documents. One advantage of working in Databricks is that the Databricks Runtime for ML contains many popular machine learning libraries such as Scikit-Learn, TensorFlow, and XGBoost. We will use the Databricks Runtime for ML to implement our latent semantic analysis in Scikit-Learn. There is a link to the notebook I'll be using in the video description if you would like to follow along. Recall that the third step in a latent semantic analysis is to perform a singular value decomposition, or SVD, on the document term matrix. Finding the vectors generated by an SVD is analogous to finding the eigenvectors of the covariance matrix of the data itself. Without going too deeply into the meaning of this, suffice it to say that these vectors are deterministic and will not change substantially with each subsequent fit of the model. In other words, as data scientists, we have very little control over the output of an SVD. We can choose a number of output vectors, but the number we choose has no bearing on those output vectors themselves. We can't tune the model in the conventional sense, that is by adjusting hyperparameters. The only hyperparameter we can tune has no bearing on the output of any one vector. The word eigen is German for own or inherent. Each eigenvector return is in some way of or inherent to the underlying document term matrix. The LSA is based upon these eigenvectors, but the SVD being deterministic, there is no way to directly alter them. What can be done is to alter the document term matrix itself. One popular method for doing this is to use the term frequency inverse document frequency algorithm in the preparation of the document term matrix, rather than just doing a simple count. A simple count collects term frequency, the number of times a word appears in a given document. A term frequency inverse document frequency, or TFIDF as I like to call it, weighs the term frequency by the inverse document frequency. In other words, we will penalize a term frequency if that term shows up in many of the documents in the body. Without going into the details of how a TFIDF is calculated, we can conceptually note that a TFIDF will help to reflect the importance of a term to a given document in the body. If a word appears frequently throughout a body, it means it doesn't carry any special information about a given document. Inverse document frequency is a numerical measurement of how much information a term provides. Here we will look at using a TFIDF to generate the document term matrix and how it affects the latent semantic analysis. This time when we generate the document term matrix, we'll use the TFIDF vectorizer rather than the count vectorizer. The TFIDF vectorizer comes from the same module in Scikit-Learn, the sklearn.featureextraction.text module. Once more, we instantiate a vectorizer with the same arguments, a min_df of 1, and using the English stopwords. Then we use that vectorizer to fit and transform our body to create a bag of words. The SVD doesn't change at all. We generate a pandas data frame of our topic encoded data that was encoded using the TFIDF document term matrix. Here is the generated encoding matrix. Let's look at the absolute values of the expressions for topic 1. We make note of two things. In the previous analysis, the first topic referred to where the wild things are. Now it refers to Goodnight Moon. The other thing to make note of is that the two most important words are literally the title of the book, Goodnight and Moon. I also like that we have more rhyming in the topic now. We have mush and brush, chairs and bears, and kittens and mittens. Let's look at the absolute values of the numerical expressions for topic 2. As expected, topic 2 refers to where the wild things are. Again, notice that the two most important words here are from the title of the book, wild and things. Once more, we will plot the topic encodings generated by the latent semantic analysis using the Python library matplotlib. First, we plot the topic encodings generated by the original document term matrix. Again, notice that we have a strong tendency along the horizontal axis for where the wild things are, and a strong tendency along the vertical axis for Goodnight Moon. But we also have a bit of noise, especially with regard to where the wild things are. Let's take a look at the plot for the topic encoded data generated by the TFIDF document term matrix. With this plot, we notice that the noise is largely gone. We do have one lingering problematic point, but that's a story for another time. This concludes our lesson on latent semantic analysis using Scikit-Learn. If you would like to learn more, you can check out our classes at databricksacademy.com.